So here I am, I'm just going to quickly wrap up and give you an overview. You might have forgotten all of the things that you've actually learned. So the first thing we came was the biodiversity topic, and really what I wanted to get you in the habit of here is exposing you to Excel. Excel is a great data management tool. So you learned about a valuable feature, which is pivot tables. You did some work in Excel. This is going to be core. If you're actually wanting to work in science, this is one of the main software applications that you will use. So we looked at index numbers, again, really introducing you to some concepts in science. We had a little bit about people interaction and the role of people in changing the landscape. We looked at biodiversity, measurements, index numbers. So I motivated index number measurement by wanting to understand biodiversity. And we really did look at some measures. So we covered the central limit theorem, which is the most, in my view, I guess the most important theorem in statistics. And we looked at descriptive statistics. So you really covered off quite a big lot of material here. We then drew a line under that, and I tried to, group things under these topics to try and make it easier for you to group knowledge together. The next thing that we looked at was energy and pollution. And this is where, for many of you, your R nightmare began. So we looked at a lot of here, and we really focused on plots. This is the most fundamental thing. If you want to be part of the scientific community, there's like a way that your plots look like, and I guess that's what I wanted to get you exposed to. You're part of a community, the science community, and there's sort of ways that we communicate, including our visuals, and that's what we spent quite a bit of time on. We looked at t-test, and I really hammered in, log transformations, and we looked at exponential decay. And so the flip side of exponential decay is growth. But this was what we essentially covered in the next block of 3 weeks. After that, we had our R nightmare continuing. Okay, so we were working primarily with our 3 flavors of t-test. You really moved to interpreting. So we had lots of examples of writing up your results. So we emphasized that. So we're conducting analysis so that we can move on to research. The research bit is actually the writing up bit. So I call, crunching the numbers analysis. Research is writing up your results. Context and theory. So we covered, we went through a lot of the ANOVA. We had exponential decay, again, seeing the decline in our fish populations. We have biological growth, where we have things following our growth pattern, again, the log coming out between things. We really tried to emphasize, again, the way that people are involved here. So in some of our fishing scenarios, we were looking at the interaction between people and science and uncertainty, all of the things mixed up together. The last module that we covered is, for many of you, I think that you're finally starting to get the hang of R. Right? So this has been my main goal in this course, to get you confident with using some R. And once you get hold of the basics, the rest just comes naturally. Okay, so pretty much the hardest step has been what you've been through this year. The remaining stuff is just all slight variations on the basics. I mean that genuinely. I've been doing this for 20 years, and it really is only slight variations on what you've seen. So here we started to look at a little bit more of the people kind of side of things, coming in the interactions, in the way we're looking at, and the decisions that we make, and the interactions between science and making judgment calls about costs and benefits. We introduced non-parametric methods, which are a particular thing of the natural sciences. So, those guys over in the business school, they're not really going to use these methods. And some of the other sciences don't really use these methods either. But for us, they're pretty important to be familiar with. And the other main topic here has really been regression. So regression is the most difficult topic for most people in the course. It's the hardest one to find, to come to terms with. Also the last one, so people are running out of a bit of steam with the course and trying to stay on top of everything. So if you didn't really, if you feel a little bit uncertain about that, that's okay. You come back to that again in later units. So that's the course. I guess one thing that I also want to highlight, is, look, obviously there are lots of things that we didn't cover. An obvious one that we haven't had time to cover is what to do with 0-1 data. So that's sort of germinate, does not germinate, something is dead or alive. So we call that binomial data, and there's a particular matching kind of regression method that we use for that kind of data. I use this quite a bit when I do my work on, are you willing to pay for some environmental restoration? And I might ask the question, are you willing to pay $50? And you'd answer yes, no, and I code that up as 0, 1. The other applications are, how many of something did I find in an environment, present, absent, that kind of thing. There are lots more things you can do with regression. You can get really kooky shapes. You can add multiple variables and interactions between those variables. It's a similar story with ANOVA. What can you do? You can have multiple factors. So the core, in science, the core setup for ANOVA is to have 2 factors. So we've had 1, but I would say 90% of the examples that I look at have 2 factors. Pretty much then a few with 1 factor and a few with 3, but almost all of them have 2 factors. So that's the other thing that you can learn. And I guess I'll end with a plug for my second year unit, which is quantitative methods for environmental management. It's a much smaller group of people that take this course. We all fit in the lab together. It's traditionally been 9 weeks of statistics and 4 weeks of some other optimization. Next year we're going to 12-week semesters, so it'll be 8 weeks of statistics and 4 weeks of optimization. And I cover those things. I guess I would say to you, if you're seriously thinking about sticking around to do a research project and a 4th year, it's really good to keep up your knowledge before you get into 4th year, and this would be a really good unit for you to take if you're thinking about going down that pathway. As I said, much smaller cohort. Most people say, thank goodness I took this unit because I had to. It was in my core. Never want to do this stuff again. That's fine. A fraction of you maybe do want to stay around, do want to do a little research project, maybe explore some of this. You don't have to take my unit. I'd encourage you to take, if you're thinking about that path, I would encourage you to take in somewhere in your program another unit in this sort of statistical methods. My unit focuses much more is, in the flavor of the unit here, where we try and look at problems and focus on writing them up. We go in and see Department of Water because I've got friends there, and we look at real problems. There are other units that are much more rigorous in their methods, which is a good grounding, like actually, much more rigorous than what I do. I try and focus on a combination of writing and methods. Some of the others are just stats, core stats units. Also excellent training for you to take. So thinking about that, please do. Don't get into your end of your degree and go, oh, I wish I'd done that. I've given you a heads up. And that, ladies and gentlemen, is the end of our time together. It's been fun. Have a good summer.